Okay, so I'm struck by the commonalities in the different things we've heard today. If you think about the last question in the public opinion panel, which was, what do you do about the people who don't answer the poll? When I think about the atmosphere, the biggest problem we have is that we have really great sampling in some places. For example, we measure something about the surface air pollution pretty well, but if you say what's going on 300 feet up, we have no information. And so we're thinking always about this problem of undersampling in various ways. How can we represent the full scale of the problem? In my work, we do this in a few different ways. So it's some combination of the visualization piece that we're talking about today and an observing strategy that, well, in the things I'll show you today, involves a satellite, where we look at the entire line of sight between an instrument that's in orbit around the Earth, going overhead in about an hour at 1:30, looking straight down, along with a network of various spatial scale networks near the surface. And then we try and assemble those into some picture of what's going on in the atmosphere that represents both the global pattern that we're seeing that's influenced by the large-scale circulation of the atmosphere and then the local. So the kinds of questions that we're interested in as atmospheric scientists have this strong intersection with public health, which is the subject of the next panel, and also the climate and weather and the public policy connected with that. And one of the questions I'm interested in is, in this context, is thinking about the consequence of the traffic we just heard about is emissions. When we move vehicles around, what we do is we burn, for the most part, fossil fuels, either right at the car or now more and more at a power plant, and then we send electricity to the car. And so one of the interesting things to follow as in the next few years is going to be that transition where we move the CO2 emissions from the traffic that Alex just showed us out to a power plant in some remote location. And so how are we going to measure that? How are we going to know that happens? In California, we have now a cap and trade strategy for reducing CO2 emissions. How do we keep that market stable by actually knowing that what people say they emit is actually what they do emit? How do we help people, mostly people of goodwill who would like to reduce their emissions? How do we help them to know that they're filling out the right bureaucratic form that says their emissions are decreasing in the way they are? So we're looking at this interface between an observing strategy, a data collection strategy, and then the visualization. So here, this is what I just told you, that we have various kinds of strategies, public policies to reduce emissions. In the images I want to show you next, we did this amazing thing in the United States, the Clean Air Act. It's an unbelievably successful public regulation. And basically what it did was it insisted that we put catalysts on all our cars, and we put scrubbers on power plants. And so we've been working with a satellite, and you could go download the data should you be interested in, but I just want to show you the change over time. So this is an image of the total amount of a key air pollutant, nitrogen dioxide, as seen from a satellite in orbit, averaged for 3 months in 2005. And so it's a map over the United States, and where there was a lot, you can pick out your favorite city. You can pick out your favorite power plant. So, I'm always struck by, here's the city of Las Vegas, and this is a 500 megawatt boiler coal-fired power plant on the Navajo Reservation, the Four Corners. This one is also a power plant. So an individual power plant puts out as much stuff as an entire city. And so that's something to keep in mind, and you can see the change. So this is summer 2011. That's after we've put controls on all the coal-fired power plants in the Ohio River Valley. So look at that enormous change there. Those are mostly power plants. But also we've controlled the passenger vehicles. And there was this little thing called a recession. The recession was actually a relatively small component of the change you saw. The change you saw was really technologies applied to power plants and cars. The other thing we do that as an atmospheric scientist, I think is great is, there are almost no controlled experiments that humans do in their environment. We do our thing in various ways. But the one thing we do is the heavy-duty diesel trucks, which are an enormous fraction of the nitrogen oxide column that you're seeing here, get off the road on the weekend. So if I show you a weekend in '05 and just, well, I'm not sure what happened there. I apologize. But a weekend in 2011 is really a beautiful improvement. All right. Well, let me show it to you this way. Instead of showing it to you as a map, I can show it to you city by city. So you can look at, in red, what's going on the weekdays. And I've just shown you summer, winter, summer, winter. Winter is high, summer is low. Because there's more sunlight and the chemistry runs faster in summer. The emissions are almost constant. And what you can see is over time, the weekends are coming down, and they're substantially lower than the weekdays. And that's entirely the effect of taking the trucks off the road. You see that at the bottom 3 panels are power plants, and you see that different power plants had different behavior over this time series from 2005 to 2011. And those different patterns are associated with the demand on those power plants and the amount of regulation that was required of them. Eastern U.S. power plants had much more regulation insisted on because they were in the midst of high-density population. The Western U.S. power plants are mostly remote from people, and so they're not as strongly regulated. This didn't transfer at all. All right. Well, that'll keep us on time. Okay, so here's another example of how to look at that. We were interested in whether or not we could see in this data set the impacts of the recession. And so what we did was we pieced out the difference in the total column in 40 different cities from '05 to '07, and there was a 6% decrease. Then from '07 to '09, there was a 9% decrease. And then from 9 to 11, it was 4%. And so that's consistent with a much steeper decline, especially in the trucking industry during the recession from '07 to '09. But you can see that the trucking industry is coming back, that there's essentially from '09 to '11 almost no decrease on the weekends, and on the weekdays relatively smaller decreases. So a sign that the economy is getting healthy again. Okay, so that's a space-based global visualization strategy that lets us pick out large areas. What it doesn't do is let us figure out what's going on at the granularity that Alex just showed us of the traffic. So if we want to know how it is that management of the freeways, as Alex was proposing, is going to change the emissions and the patterns, if we want to know what's going to change about CO2 as a result of that, or the nitrogen oxides, those are both co-emitted by cars and trucks, then we need some other strategy. This is the densest network of surface stations anywhere in the world. This is the California Air Pollution Monitoring Network. And every red dot is a place where we have measurements near the surface. And you can see that compared to the area of this map, there's a lot missing. But that's what we work with. And so the strategy has to be some way of merging the satellite, which goes over once a day at 1:30 in the afternoon, with the continuous record that comes from these stations, but it's very spatially sparse, with some other kind of information or a model or some visualization. Here's one example that we've been thinking about. The question was, what happens to air pollution as a function of temperature? This is, in this image, it's the fraction of days that are in violation of the state health standard. And this is near Bakersfield, and so this was days that was hot and super hot, which is really your choice in Bakersfield. And what was interesting about this is that an ordinary strategy would lump all this together. But what we were able to show, dividing it by temperature, was that there's really very different patterns when it's hot and when it's super hot. And that allowed us to figure out some options for policymakers going forward. But this is not a useful public visualization in that sense. It's a useful test of our scientific knowledge that we can then use as a summary for policymakers. So let me finish up by saying what we're trying to do going into the future, which is really to address this other policy question, which is how will we know if we're reducing CO2 or other greenhouse gases? How will we know if those policies are effective? And when will we know if they're effective? Here's a global picture. In a global average sense, CO2 is rising. Look at that, just that first panel. That's a 25-year record. And in the summer, trees grow and they bring out their leaves. And so the planetary amount of CO2 goes down as we transfer some CO2 into plants. And then in the winter, all those leaves rot, and we put that back in the atmosphere. So there's a large seasonal cycle in the global amount of CO2 in the atmosphere. And then that long-term increase from burning fossil fuels. If we're going to control the temperature of the planet, that increase has to stop. And there's lots and lots of different players at all kinds of different policy levels who are trying to do something about that. So what kind of information can we give them? All of those players are, for the most part, local. There's no planetary government doing anything about this. So this is the slide I often use in graduate student recruiting, saying that the center of the universe is Berkeley. But it's also, everyone can make that map, and the center of their policy universe is where they live. Think global, act local. So what can we do to give policymakers in their own city the right kind of information to say, here's 25 things you're doing, these 7 work really well, those 18 are not working really well, redirect your efforts to the things that are working. All right, let's see, those other images didn't work. Let's see if this movie works. Okay, excellent. So here's a model we made showing a time series of CO2 at the surface around here. And so this is an idea, and to be honest, I have no idea if it's right. I have some basic notion that we put the right physics and chemistry in this model, but I'd really like to know if what we're seeing here is correct, because that would let me say that the fundamental sources in the model, the cars, the trucks, the power plants, the home heating, all the different things that contribute to CO2 in our atmosphere are in the right place in the right amounts. So what we've been trying to do is to figure out an observing strategy for doing that. And the observing strategy, you see a piece of it here. Everywhere you see a dot on this map of Oakland, this Google Earth image of Oakland, we're putting down a CO2 sensor. And we're going to be able to use that to try and figure out at the kind of level of detail of that beautiful traffic map that Alex showed you, where the CO2 is coming from and how it's getting into the atmosphere. And then we'll watch over the next few years in time how that changes. This is a project that's got, so that's the science policy objective. It's got a parallel piece that's about K-12 education. So most of those dots you see are on the roofs of elementary and middle schools in the area. And what we've done is to try and put together a climate change education story using the data on the schools so that kids in those schools can be motivated to think about CO2 in their vicinity. And it's that synergy that is one of the exciting pieces about what we're trying to accomplish. The other thing we have is, you see that this dot way up here is at the Chabot Space and Science Center. And we have another one going in next week or in a couple weeks across the bay at the new site of the San Francisco Exploratorium. So we're interested in the museum visitor experience of how to look at this CO2. And so I'm interested in being here to hear about ideas for visualization. My fantasy about this data set is that we'll be able to produce an image that looks like the evening fog rolling in on the news, and to show you how CO2 is playing out in our community with those kind of visual images that let people think about how it varies day to day and how it varies from different kinds of sources. But we're in that data collection phase where we're figuring out how to make the measurements that would then feed that visualization. But I think there's an interactive component to this of what is the strategy for getting data that allows you to make the images that are both interesting and persuasive. So if you want to learn more about that CO2 project, I'll refer you to this website. And thank you for your attention.